Students, Assalamu alaikum. We are learning physics for grade 9. This is lecture number 3 for week 1 of second term. Let's have recap of the previous discussion. In first lecture, we started with basic introduction of physics. Physics is the study of matter, energy and their interaction. Branches of physics are mechanics, heat, sound, light, electricity and magnetism, atomic physics, nuclear physics, plasma physics, geophysics. In second lecture, we talked about physical quantities. Physical quantities are measurable quantities. For example, length, mass, time, weight, volume, distance, speed, acceleration, force, momentum, etc. System International, that is SI units of physical quantities, are the standard that assign the appropriate unit for a particular physical quantity. For example, for length we have meter, mass is expressed in kilogram, time in second, weight in newton, volume in cubic meter, distance in meter, speed in meter per second, acceleration in meter per square second, force in newton, momentum is newton second. This is the table for base quantities and their SI units. The first column represent the physical quantity. There are 7 base quantities, and third column corresponds their SI units. SI unit for length is meter, for mass is kilogram, for time is second, electric current is represented by ampere, intensity of light has candela as SI unit, temperature is represented by Kelvin, and SI unit for amount of substance is mole. Some of the derived quantities and their SI units with symbols. The first column represent some of the derived quantities, and third column represents their SI units. SI unit for speed is meter per second, for acceleration meter per second, volume cubic meter, for force newton, for pressure pascal, for density kilogram per cubic meter, for charge coulomb. Dear students, let's start with today's discussion. The topic for this third lecture is significant figure. Significant figure is defined as the significant figures are all the digits that are known accurately and the one estimated digit. It can also be defined as all the accurately known digits and the first doubtful digit in an expression are called significant figures. As significant figures are the numerical expressions of measured physical quantity, so an improvement in the quality of measurement by using better instrument increases the significant figures in the measured result. Rules for significant figures or digits. The following rules are helpful in identifying significant figures. Rule number 1. Non-zero digits are always significant. Mean the digits other than 0, that is 1 2 3 4 5 6 7 8 9. These all non-zero digits are always significant. For example, 27, there are 2 significant digits. 275, there are 3 significant digits. Rule number 2. Zeros between 2 significant figures are also significant. For example, 2705 has 4 significant digits. In this example, and 5 are non-zero, while 0 comes between 2, 7 and 5. That's why it is included as significant. So 2705 has 4 significant digits. Rule number 3. Final or ending zeros on the right in the decimal fractions are significant. For example, 275.00 has 5 significant digits. Rule number 4. Zeros written on the left side of the decimal point for the purpose of spacing the decimal point are not significant. For example, 0.03 has 1 significant digit, 0.0275 has 2 significant digit. Dear students, let's have some more examples to clarify the concepts of significant figures. Example, if the numerical value is 1.009, then according to rule, all 4 digits are significant because zeros comes between non-zero digits 1 and 9. That's why there are 4 significant digits. Next example, suppose the numerical value is 0.00450. Here there are only 3 significant figures which lie on the right hand side, while these zeros are non-significant. So this expression has 3 significant figures. Next example is dealing with numerical value in scientific notation. So let's see, 1.66 into 10 raised power minus 27. In this expression, the rule is the numbers which are associated with 10 raised power are the significant. In this example, these 3 numbers are significant because these comes before the 10 powers. So this is the rule for significant figures for an expression which is in scientific notation. Next expression is 2001. Again, there are 4 significant figures. We just learned that if we express any numerical value into a scientific notation, then let's convert this into a scientific notation. The point here lies at the end. If it is taken to this point, mean after first non-zero digit, so how many places we have to move towards left? 3 places. So it can be written as 2.001 times 10 raised power 3. So here how many significant digits are there? These are the significant digits. So there are 4 significant digits because these comes in the expression in the form of scientific notation. So this is the rule for significant figure for any expression which is written in a fashion of scientific notation. Here you also come to know that how to change any expression into a scientific notation. We are only to shift the point either towards left or towards right. If the decimal point is shifted towards left, 10 powers positive, and if the point is shifted towards right, 10 powers negative, in corresponding to the number of places for which the point is shifted. Let's take another example. Suppose we are having 0.023. So if we convert it into a scientific notation, then this point is shifted here after first non-zero digit. So it would be written as 2.3. And how many places for which the digit is to be taken towards right? 2 places, so 10 raised by minus 2, as I just told you the rule for converting any expression into a scientific notation. So how many digits are there which are significant? These 2 digits. The last and fifth rule for significant figure is, in whole numbers that end in one or more zeros without a decimal point, these zeros may or may not be significant. In such cases, it is not clear which zeros serve to locate the position value and which are actually part of the measurement. In such cases, express the quantity using scientific notation to find the significant zeros. Take an example of the numerical value 6000. Here there are 4 digits, 3 are zeros and 1 is non-zero. So in this expression, it may be all 4 are significant, it may be 3 are significant, it may be 2 are significant, or it may be only 1 is significant, depending upon the kind of instrument and the measuring unit. Dear students, there are different terminologies which are associated with significant figures. The first one is the precision in measurement. What is it? Significant figures reflect the precision of measured value of a physical quantity. That is, more significant figure means greater precision. For instance, if I write 27.4, in this expression there are 3 significant figures, and if I write it like 27.43, as this expression contains 4 significant figures, so all significant figures are, all digits are significant. So first expression contains lesser significant figures 3, and second expression contains more significant figures, that is 4. So more number of significant figures reflect more precision in measurement. So we conclude that this expression is having more precision as compared to the upper one. The second terminology is accuracy in measurement. What is it? The accuracy in measuring physical quantity depends upon the following factors. Number 1, the quality of measuring instrument. Number 2, the skill of the observer. And number 3, the number of observations made. So accuracy in measurement of a physical quantity is described by 3 points: quality of the measuring instrument, the skill of the observer, and the number of observations made. So what is meant by it? If we use better instrument, that is, if the quality of the instrument is more, the accuracy in the measurement is more. The second point is skill of the observer, mean more skilled, more experienced observer can get more accurate measurement. And the third point is the number of observations made, mean more the number of observations made for a given experiment, for a given setup observation, more would be the accuracy. So these 3 points are very clear as far as accuracy in measurement is concerned. Dear students, finally let's have some more practice regarding the finding out the significant figures in a certain numerical value. There are 2 ways. One is for remembering the points which are just we discussed, and second one, that is alternative method, and easier one is just to convert a given expression into a scientific notation. So let's start with example A. The expression is 100.8. So if we convert it into a scientific notation, then we have to plot this point here. So how many places we are to move the point to left? 2 places. So in scientific notation we can write 1.008 into 10 raised to power plus 2 as we move towards left. So how many digits are there along with 10's power? 4. So it has 4 significant figures. Let's take the example B. The expression is 0.00580. So let's convert it into scientific notation. We have to take this point after 5, mean 3 places towards right. So in scientific notation it is written as 5.80 time 10 per -3 as we move 3 places towards right. So how many significant figures are there? The significant figures are 3, which comes before the 10's power. The last example is C. Here the numerical quantity is 210.0. So let's convert it into a scientific notation. We have to take this point at this place after one non-zero digit, mean 2 places towards left. So in scientific notation it can be written as 2.100 times 10 raised to power 2. So here we got scientific notation. So how many digits are there along with the 10's power? 4. So this expression after converting to scientific notation carries 4 significant digits. So I think it's more easier way, or you can say the alternative way to find out the number of significant figures if we convert any numerical quantity into scientific notation. So dear students, it's all about today's discussion. Hopefully you got understanding what are significant figures, how to find them, what is scientific notation, how to convert ordinary notation into a scientific notation, and we got two related terms to significant figures: the precision in the measurement and the accuracy in the measurement. So see you next time with next lecture for second week of your second term. Good luck.